Alright, so for our next part here, we're dealing with angle theta in standard position and has a terminal side that consists of the point -5, 3. And we want to find the exact value of the 6 trig functions. So the main three are your sine, cosine, and tangent. So sine is equal to your opposite side over the hypotenuse. And then cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Or similarly, from a graph, you could also write those as y over r, x over r, and y over x. Where in terms of your graph here, so let's try and graph this so I can show you what we mean in terms of this specific point. So once again, we have our x and our y here. So we have -5 for the x, so we go left 5. And then we had 3 for our y, so we go up 3. Something right around here. And then just like in number 3 in the last video, here for our terminal side, we would have that connect down to the origin to create our line segment there. So whenever we're drawing in the triangle from these, we always want to connect whatever that terminal point is. So whatever that point is on the graph, we want to connect it down to the x-axis. So depending on which x-axis is closer to you, whether it's the positive one or negative one, depends on which one you connect to. But to form your right triangle, you never connect it to the y-axis. It will always be to the x-axis. So let me change colors here to show you a different color here. We would be connecting this down to the x-axis here. So for our right triangle here, we're really dealing with this triangle here. And once again, remember the point here, we had our x value was -5, so this side has a length of -5. Let's go the negative direction. And the y value is 3, and it was a positive 3 there. And then either way here, to figure out the hypotenuse, or to figure out r, both of those are the same value. So let me try and make this triangle a little bit bigger here, but off of the graph here, so that way we can zoom into it a little bit here. Our angle theta that we're dealing with here, we'll label it in here. And this is what's also called a reference angle, which we'll deal with a little bit more here later on as well. So this theta, the values that we're going to get for our trig values there will be the same as what we get if we did this entire angle from the x-axis to that. So both of those would give us the same values in terms of our sine, cosine, and tangent. And then in terms of our other 3 trig functions, the secant, cosecant, and cotangent, that will also be going through here. So here we had this side was 3, this side was a -5. So to figure out this third side, remember this is a right triangle, we can use that Pythagorean theorem that we've used before. So here we'll write it off to the side, we have our 3 squared plus the -5 squared equals our c squared. Try and get that other side there. So here we'd get a 9 plus 25 equals c squared. So we get 34 equals c squared. And then remember to get c instead, which remember c always represents the hypotenuse, or the r in terms of the graph. R just represents, if you're thinking of this in terms of a circle, it represents the radius of the circle that would be formed by our point. So here we get then the square root of 34 would be equal to our c. Because remember the squared and square root cancel each other out. So that means our hypotenuse in this case is the square root of 34. And then some of these, just like some of the other ones before, they might have you try and simplify the square roots. I'm not too concerned in terms of you doing that as long as you know how to work with whatever square roots you have. remember, if you are trying to simplify square roots, you're looking to see if there's any perfect squares that go into there. So like 4 or 9 or something like that, that divides into that 34, which in this case, there's no perfect squares that divide into there. So it's already simplified. So if we're trying to figure out our original sine, cosine, and tangent, first of all, for our sine over angle theta, have opposite over hypotenuse. So since our angle is down in that bottom right corner, our opposite side, so the side opposite of that, is the 3. So this is our opposite side. We'll abbreviate it here, which means this is our adjacent side down here. And then our hypotenuse is that square root of 34. Or you can also label these as your y and your x and your r if you're writing it in the other notation. Both of them are the same thing. They're still representing the same numbers, just a matter of whichever you think is easier to remember there. So here in this case for our sine, we would have 3 over the square root of 34 there. And I'm fine with you leaving that square root in the denominator. I think in some of the homework problems, they may have you what they call rationalizing the denominator to get that out of there. I'm fine with you leaving it down there. So in the homework problems, just like normal, if you're not quite sure if yours is equivalent to theirs or not, you can certainly ask. I can come around and answer those questions as well. Or you can click the Ask Instructor and send them to me. I'm fine with you keeping those square roots in the denominator. That's fine with me. At this level in the game, since we're just in the basic math class, we're not dealing with the harder trig stuff. And then for cosine, you're doing the same sort of thing here, but now we're dealing with the adjacent side and the hypotenuse. So we'd have the negative 5 over that square root of 34. And then for tangent, same type of thing, except for now we're dealing with the opposite over the adjacent. So we'd have our opposite, which was 3, over the adjacent side of the negative 5. And make sure for any of these, if you were to have both negatives for the opposite and adjacent, make sure that if you're doing a negative over a negative, make sure you write your final answer as a positive number. Because if you have a negative and another negative that you're dividing, remember your answer is positive. So then for the other 3 trig functions here, they're just reciprocals of the ones that we already had. So here, for instance, we have cosecant, which is abbreviated as CSC for cosecant. So the cosecant of theta is the reciprocal of our sine. So here, be equal to square root of 34 over 3. And then our secant, the next one here, secant of theta is the reciprocal of cosine, so I'll write it beside the cosine. So you'd have then the square root of 34 over the negative 5. And the same type of thing with tangent, you have cotangent is the reciprocal of your tangent, so you'd have a negative 5 over 3 then. So you're just flipping those fractions to then get those last 3 trig functions. Cosecant, secant, and cotangent, once again, are reciprocals of those. Or you could also write as 1 over those. So you write that off to the side here as well. So we could also write it, for instance, that secant theta is equal to 1 over cosine. Cosecant of theta is equal to 1 over sine. And that your cotangent of theta is equal to 1 over tangent. So in other words, they're always reciprocals of each other. And once again, some of these, they might have you go through and simplify if you can. So you do want to make sure with your fractions that you're checking to see if those fractions can simplify, if there's anything you can divide out of the numerator and denominators there. Like normal, if you have questions on any of this stuff, make sure that you are asking. This stuff is definitely trickier than some of the other stuff we've done before. And then for number 5 here, if we have cosine of theta is equal to 4 over 7, what are the other 5 trig functions? So you're still using the sort of stuff that we had from up here in terms of our SOHCAHTOA. This is normally the one that's most useful to use because we can use that even if we're not graphing them. So here, let's try and draw out this right triangle here first of all. And then depending on which angle you label as your theta, it's going to just depend on which sides are going to be your 4 and your 7 there. So let's say, for instance, let's mark this top angle as theta instead, so you don't get used to it always being in that same spot. So if theta is up there, then that means your opposite side is the one down here along the bottom, and then the adjacent side would be on the left side this time, and then the hypotenuse is always across from that right angle. It's that longest side. And then remember for cosine, that's the ka part of the SOHCAHTOA. So it'd be adjacent over hypotenuse. So you'd have adjacent over hypotenuse, so you'd have the 4 and the 7 along there. And then once again, you would have to go through and solve for that third side there to try and figure out then what those other 5 trig functions are. So you'd want to use that Pythagorean theorem again. But keep in mind, it's not the c we're solving for this time. We know what the hypotenuse is. We're trying to solve for one of those other sides. So you can label as either the a or the b. It doesn't matter which one. They're both legs of the triangle. They're both along that right angle. So here we'd have then 16 plus b squared is equal to 49. And then just like normal, we'd want to try and get that b by itself. So here with that 16, so positive 16, we'd want to subtract 16 from both sides. And then that cancels. So then we have b squared is equal to, let's see what we get here. I didn't write this one down ahead of time, so it looks like we get 33 there. So 33. And then we would do the square root of both sides, so we get b is equal to then the square root of that 33 there. So make sure, like normal, that you are going through and showing all of your work for these. Make sure that you get them set up correctly. And then here, to figure out your other trig functions now, you're going to use what we have for those opposite, adjacent, and hypotenuse sides. So I'm going to label it on the triangle here, make it easier for us to label them. So we already had cosine, so we could do, for instance, sine next. So remember, sine is the SO part of SOHCAHTOA, which is opposite over hypotenuse. So we'd have square root of 33 over our 7. And then for the tangent, we have opposite, which is the square root of 33. So don't get used to them all being in the same spot every time. You always have to label which one's opposite, which is adjacent, and which is hypotenuse, so that we get these correct. So that would be in terms of your tangent there, the opposite over your opposite over adjacent for tangent. And then we already had our cosine. So remember, secant is the reciprocal of your cosine value. So secant then would be 7 over 4, since that's the reciprocal of cosine. And then for your cosecant is the reciprocal of sine, so you'd have 7 over the square root of 33 there. And then for your cotangent, remember that is the reciprocal of your tangent. So for that one, we would have then 4 over that square root of 33 there. Let me write that one a little bit better there. It's hard to read in the bottom there. 4 over the square root of 33. That's what that one says. So make sure that you are writing all of those out and showing all of your work for those like normal. And you'll notice a lot of these you do still have to use that Pythagorean theorem to go through and solve those. And then we'll go over number 6 in the next video.